All right, so let's go over this. It says for dilations, there's two facts you should know. If you dilate something, the angles are congruent, the sides are in proportion, right? So if you have something like this here, um, the proportion, we'll call it K, because this is going to be always image over pre-image, right? That's just the definition. Um, so this is always true for all the sides, right? So this question says triangle A prime B prime C prime is the image of ABC after dilation of 2. So I drew it like this. So all the angles should be congruent, right? If this is ABC, if this is A prime B prime C prime, yeah, these should all be the same. So that's why the answer should be choice 3, right? So the second question, it says triangle is dilated by a scale factor of 3. So this is another fact, right? So if we think about this, if we have we'll just have a simple shape like a square. If you take a square, let's just say you double all the sides. If this is L, this is 2L, this is W or something, this is 2W. Um, then since we're multiplying two dimensions by the scale factor, that ends up being scale factor squared. So I would say like the simple way to think of this is length. The new length is the scale factor times the old length. Right? And then if you have area, the area is scale factor squared times the old area. And the volume is going to be the scale factor cubed times the volume. Because you end up multiplying the scale factor for each of the dimensions. In volume, there's 3 dimensions. So for this question, it says if it's dilated by a scale factor of 3, right, then it means that this is going to be times 3. Maybe I should have done 3. Like this would be times 3, this would be times 3. Oops. And then it would end up being something like 3 times 3. And then, okay, yeah, it would end up being something like 3 times 3, which would be like 9 times the old area. Okay, this one, it says something is dilated by a scale factor of 0.5, which means it's getting smaller by a half. Which statement is true? Basically, you kind of want to just go through the choices, right? So if you have the angle, well, we know angles should be congruent. You can cancel out 1 and 2. For choice 3 and 4, you just have to think, right? The new thing, t prime a prime, is smaller than the old thing. So then you have to double it to make them equal, right? Okay, for this question, for number 4, it says the triangle is dilated by a scale factor of half, centered at point B, mapped onto CDF. All right, they didn't draw it that way, but that's okay. If measure angle DFC is 40, so I guess I'll do DFC is 40. What's the measure angle of HJG? HJG. Yeah, so these correspond, right? I kind of um underlined it here, but the middle letter is the angle, right? And F and J, they also match up. So yeah, if this is 40, this is also 40. Okay, and then the next one, so this is kind of number 5 is testing like do you remember what you divide by what? Right? So it's always the new thing divided by the old thing. Yeah, new divided by old, or it should be image divided by pre-image. That's like the geometry word. Um, yeah. So like if something doubled, right, it would be, let's say 10 and the old thing is 5, that should give you a scale factor of 2. Yeah, everything should work out. Okay. So if you try out all the choices, like if I do choice A, AC over AE, like the bigger thing divided by the smaller thing. Wait, sorry. So it says ADE is the image. So it actually got smaller. ADE is the image of ABC, right? So yeah, we gotta do the new thing, which is the smaller triangle, divided by the old thing, which is the larger triangle. So AC over AE, that's the larger triangle over the smaller triangle, so that's not it. Choice B is AE, smaller over the longer, which yeah, that's our answer because they match up also. Um, yeah, that's it. Okay, and then this I did here, right? So basically, we have the triangle that they already sketched, um, and then it says there's transformations that they did. The first one, it says a dilation scale factor of 2, followed by a translation 3 units to the left and 1 unit up. So let's take care of the first thing first, right? So if I do that, hold on, maybe I'll get rid of this, like the second transformation. So how would you, no matter of fact, let me just do it all over again. Okay, so yeah. So the first thing I want to do is take care of dilation by scale factor of 2. So this is the way you want to do this. I think this is like the best way. You could think of it like, because it says centered at the origin, wherever the center of dilation is, the distance from there, if the scale factor is 2, you want to double it, right? So for instance, here to here is like that. So you just want to do that again, since it's twice the distance. So maybe you can think of it as, yeah, it goes to the right 3 and up 1. So same thing, right 3, then up 1. Yeah. So this is the new G prime. And then for H, it's to the right 5 and up 3. The right 5 up 3. This is the new H prime. And then for S, it's to the right 1 up 4. So right 1 up 4, that's the new S prime. All right, and then if we were to just connect these, all right, let's just say that looked nicer, but that's okay. And then it says followed by a translation, 3 units to the left, and then 1 unit up. That's pretty straightforward. 3 to the left, 1 up. Yeah, 3 to the left, 1 up. 3 to the left, 1 up. So this is the new S prime. This is H prime. Sorry, H double prime, and then G double prime. That's it. Okay. And then a question like this, like, is it congruent? No, usually the answer that they're looking for is there's not a series of rigid motions to map these two together. Okay, next. This is the same one. So for this one, originally they gave us this. I'll do this again. Originally they gave us these 4 coordinates, and I think, yeah, you just graph them, and then it says after a dilation of scale factor a half centered at the origin. So we're gonna do the reverse, right? So this is I guess 2 left, 2 up. So instead we're gonna do half of that, which is 1 left, 1 up. So that would end up like right here. This is the new A prime. And then this is originally 4 left, 4 down. So you do half of that, 2 left, 2 down. This is D prime. And then this one is to the right 8, down 4. So it's to the right 4, down 2. This is B prime. And then the last one is C, which is right 6, down 10. Half that, so it's right 3, down 5. So that's C prime. Yeah, let me just connect these. Right, and then that's it. Yeah, that's how you can do scale factors. Now, if it's not centered at the origin, wherever the center of dilation is, like let's say I could do the same question. Let's say I put the center like somewhere like here or something like that. Then you can do the same steps, right? You just figure out, okay, from the center of dilation, how far away is each point? So for A, it would be, it's 4 to the left, 2 down. So then you would half that, which is 2 to the left, 1 down. Right? And then same thing for all the other points. You just kind of map out the distances and just do half that. Right, so it's like 1 to the right. I don't know what I did, but like, yeah, half of that down. I guess that's like, it might be 5. Yeah, it's gonna be like in between. It's like somewhere here. Because I think this is 9, so it's like 4.5. Okay. And then this one, did I not do this? Triangle QRS is graphed on the set of axes below, on the same set of axes graph and label QRS, Q prime, R prime, S prime, the image after a scale factor 3/2. Okay, yeah, I didn't do this one. So a scale factor of 3/2 centered at the origin. So what we're gonna do is we're gonna take 3 halves. So I guess you could divide it by 2 times 3. That's easier to think about. It's centered at the origin. So we're gonna start here, right? And then we're gonna take this distance. We'll do R first. We're gonna take this distance, divide it by 2, right? That's just 1 unit of 1 times 3. That brings us here. So this is our R prime, our new R. And then we'll do Q next. Yeah, so it's to the left 2. So cut that in half times 3. So over here. And then it's up 2. Yeah, we're not done with this. It's up 2, so same thing. Cut that in half times 3. So this is our final Q prime location. And then for S, okay, and then for S, it's to the right 4, right? So half that is 2 times 3 is 6. So that would go over here, and then we gotta also do the vertical. So it's up 6. Yeah, it's up 6, so half that times 3. Yeah, like that. So this is S prime. Yeah, and you don't have to do it that way to do like 3 over 2, but yeah, if doing times 1.5 makes sense, that's also okay. Right, like if you wanted to do, this is 2 times 1.5 is 3, right? And then this is 3 times 1.5 is 4.5. Sorry, that's not 3. This is 2 and times 1.5 is 3. And then this is 2 times 1.5 is 3. And then this is 4 times 1.5 is 6. Yeah, whichever way makes sense for you. Okay, and then what else? So just connect these. Next question says, okay, next question says, use slopes to explain why these are parallel. Q prime, R prime is parallel to QR. Yeah, why are these two parallel? Yeah, I guess it says use slopes. So you can find the coordinates and just do, okay, so we'll do slope of QR. This is, hold on, maybe I should just write all the coordinates. So Q is negative 2 comma 2. R is 2 comma 0 comma 0. Q prime is negative 3 comma 3. R prime is 3 comma 0. Yeah. Okay. So then slope of QR is change in y 2 minus 0 over negative 2 minus 2, which is 2 over negative 4, which is negative a half. And then slope of Q prime R prime is going to be change in y over change in x equals 3 over negative 6, which is also negative a half. Yeah, so I guess you could show it this way. All right, that is good.